Okay, now we're going to move on to calculating mass and number of moles. The student objectives here are calculating number of moles and calculating the mass of a compound. Now, this is essential. I mean, what we're using here now, you are literally going to use, Chem 20, Chem 30 in your science courses, Science 20. This is a huge calculation. I would like to refer you, I am going to post a lesson, or sorry, a quick video or recap on significant digits. I'm going to post that at the very beginning of the course, and I just would hope that you've had a look at that, and that's going to help us answer some of these questions correctly. Anyway, if you want to follow along in the textbook, we are essentially going to be, we're kind of holding tight. We've been looking at molar mass, but essentially we're still around page 108 to 109. Okay, 109, those are your pages right now. One last piece of information. You must understand how to calculate molar mass. I mean, I know that's only one lesson back, but that has to be essentially a mastered skill, because if that's not mastered, we're going to have difficulty figuring this next part out. Okay, so there's a basic formula that we use here. Now, the formula looks generally, it's mass, and that's in grams. Okay, it's N, which is moles, times capital M, which is molar mass, which is in grams per mole. So here we go. Now we're going to abbreviate that. We're going to go M equals NM. So of course there's no symbol in between, that's multiplication. There is another derivation of this formula using algebra. Some people use a triangle method. I'm not going to do that. The other form of this, so you would use this, when would you use this? You would use this when you want to find, well, what's it isolated for? Mass in grams. The other derivation of this formula is N equals mass divided by molar mass. Well, when would you use this? When you want to find moles. Okay, so basically here, these are two versions of the formula, and you're going to use one or the other based on the question that you have in front of you. You are going to notice that in both of them, molar mass is there. It may be given for you, it may not. My advice would be to memorize this formula. You see, if you memorize that formula, you'll always have it solved. You'll always have the equation for solving for mass. But what if you wanted moles? Well, instead of remembering that, think to yourself, how can you get this N by itself? I use algebra. Now you see, I need to get this N by itself. There's multiplication here. In algebra, you undo. The opposite of multiplication is divide. If you divide by molar mass, it cancels on that side, and you must do the same over here. So what you're left with is moles equals mass divided by molar mass. Anyway, we'll move on. The calculations are straightforward, but I just want you to be familiar with this formula. Let's try some examples. All right, let's calculate the mass. So it's going to, a typical question, this is out of your textbook. What is the mass of 10.0 moles of water? Okay. So which of your two formulas are you going to use? We're going to use M equals NM. So we need to know our moles and our molar mass. Well, luckily in this question, they have shown us that we have 10 moles. Oh, and by the way, this is the work that you are expected to show. Number 1 is the blank formula. Number 2 is the inputting with units. So you would put 10.0 moles, put that in brackets. The molar mass of water, now you'd have to show that. So water is H2O, so you would go H. It's 1.01 grams per mole times 2, and of course that's going to give you, well, 2.02 grams per mole. Oxygen is 16.0 grams per mole. We only have one of those, so that's 16.00 grams per mole for a grand total of 18.02 grams per mole. Now that's your molar mass, everybody, so that's going to go into our formula, 18.02 grams per mole. You'll notice that I had my blank formula. I've inputted my values with units, and now it's a simple, straightforward solution. The answer you're going to get is 180 grams. Now, in accordance with significant digits, this answer is correct because you can see in our question, the lowest number of significant digits we have is 3. This means that our answer must also have 3 significant digits, which it does. Again, focus more on the content here right now. Don't make a big deal about significant digits at this point in time. Let's try another example. Okay, let's go here. What is the mass of 13.50 moles of, let's say, magnesium bromide? Okay, so a couple things we have to do right here. Let's start with our formula. So M equals NM, that's my blank formula. Step 2, let's start inputting. We have 13.50 moles. I need my molar mass of magnesium bromide. Well, guess what? We need to figure out that formula. Mg is 2 plus. Br is 1 minus. Our formula is MgBr2. So, think of it, everybody. What if that formula was wrong? If that formula was wrong, we would get a wrong molar mass value, which would mess up the entire question. You must have the formula correct. Mg is, I'm sorry, I just put my book away for a second. Mg, the atomic molar mass of that is 24.31 grams per mole times 1, which is 24.31 grams per mole. Then we have our Br, and Br is 79.90 grams per mole, and we have 2 of those. So that's going to give us a total of 159.8 grams per mole for a grand total of 184.11 grams per mole. That value can now be inputted into our formula with units. Now we'll do our calculation. Whoops, 13.9. Now, here you go. Here is your answer. You get 245.485 grams. Mathematically correct, but not correct in regards to significant digits. In our question, we have 4 significant digits. This means our answer can only have 4 significant digits. So this 4 does not round this up. So 2485 grams. That's your final answer. We could do one more. Let's see if we can go all out on this one. Let's do mass of, let's say, 3.25 moles of, let's just go with, let's go cobalt 2 sulfate. All right, so 1 M equals NM, 2 M equals 3.25 moles. What we are lacking is our molar mass. So we need our formula here, everybody. That's CO2 plus SO4 2. Oh, this actually works out pretty good. They are perfectly balanced. So we have COSO4. So we have CO is 58.93 grams per mole times 1, which of course is 58.93 grams per mole. Then we have sulfur. We have one of those, so that's going to be 32.07 grams per mole times 1, which is 32.07 grams per mole. And finally, we have oxygen, which we have 4 of them, and oxygen is 16.00 grams per mole times 4. Now, I hope you're getting the hang of this. It's somewhat repetitive, and I hope that it's becoming easier for you. I'll just total this up really quickly here. Plus 32.07 plus 58.93. That gives you 155 grams per mole. We'll input that value into our formula. 155 grams per mole. Our final answer for mass is 503.75 grams. We have 3 significant digits, therefore our answer must have 3. 1, 2, 3. This one is going to round that up, so it's going to be 504 grams. All right, let's kind of change gears here now. Let's calculate the number of moles. Again, fairly straightforward, just using the formula, as long as you don't have mistakes with your molar mass. So again, remember we're using, this was our one formula. Now we are using this formula. Okay, so we'll do pretty easy here. How many moles of silicone in a 56.18 gram sample? Well, this is right out of your textbook. So number one, let's start with our formula. Let's input what we can. Remember the little m is your mass, so that's 56.18 grams. What we are lacking is our molar mass. So silicone, well, pretty simple. We just have one silicone. And the silicone value is going to be 28.09 grams per mole. We'll sub that into our formula. Grams per mole. And this is going to be a simple division question. 56.18 divided by 28.09. Whoops, and I hit multiply. That's going to be way too big. 56.18. This should come out exactly to 2 if I'm doing it right in my head. And it does. Now what you get here is 2 moles. Now, but is that right though? If you look at your question, you have 4 significant digits, which means we must have 4 significant digits. 2.000 moles. Okay, there you go. All right, maybe we'll try a bit of a harder one. Let's go with find the moles in 28.5 grams of, let's go, sodium phosphate. Okay, so step 1, here's your formula. Step 2, input what you have. We need molar mass. So sodium sulfate. Sodium is 1 plus. Sulfate, or sorry, phosphate, not sulfate. Phosphate is PO4, and actually I believe phosphate is 3 minus, not 2 minus. Phosphate is, why can I not find it? It is 3 minus. So in this case, when they form a compound, we're going to have Na3PO4. So sodium is 22.99 grams per mole times 3. And I'll do that for us really quick. 22.99 times 3 is 68.97 grams per mole. Then we're going to have one p-value. Phosphorus is 30.97 grams per mole times 1, so 30.97 grams per mole. And then how many oxygens do we have, everybody? It should be 4 of them. 16 grams per mole times 4, 64 grams per mole. I'll total this up, plus 30.97 plus 68.97, grand total of 163.94 grams per mole. That's your molar mass. We'll sub that over, 163.94 grams per mole. Now this is a division question. 163. All right. So we have to have 3 significant digits. Your answer should be 0.174 moles. There was some rounding in there. One more if you want to see it. Okay, we want moles. And I'm going to try to make this one a little bit trickier. Let's go with, I want to find something. Okay, we'll go find the moles. We're going to have 50.9 grams of chromium 3 sulfate. All right, so N equals M over K. So we have 50.9 grams. Need the molar mass. To get molar mass, we have to have the right formula. So chromium is Cr, that's going to be the 3 plus version. Sulfate is SO4 2 minus. I hope by now you're okay with me skipping a step. I'm going to put this together. It should be Cr2SO4. Remember, we have 3 of these now, bracket. Okay. Chromium is 52.00 grams per mole times 2. I'll do the math at the end. Now, how many sulfurs do we have here, everybody? We have 3 of them. So sulfur's value is 32.07 grams per mole times, we have 3 of them. And then how many oxygens? Now oxygen is 16.00 grams per mole times 3 times 4 is 12. All right, now I'll start doing the math. And I know you're kind of laughing because of why am I doing the simple stuff? Well, I don't want to make a mistake. 32.07 times 3, 96.21 grams per mole. And this is 16 times 12. 192 grams per mole. Grand total of gives me 392.21 grams per mole. We'll sub that in over here. It's going to give us a final answer. We need to have 3 significant digits. Wow. It starts out like this, 1, 2, 9, 7, 7, 7, dot, dot, dot. So we're going to have 3 significant digits, but this is going to round up to 9, while that's going to give us the next 10 group. So your final answer should be 0.130 moles. Sorry. All right, everybody. We're definitely going to need some practice with this. Again, you're going to notice that it all comes down to actually the molar mass. And where does the molar mass come from? It comes from having the correct formula. Can you imagine they said chromium 3 sulfate and you didn't write this formula correctly? That's going to change your molar mass value, which means you never have a chance at the right answer. Please ensure you are getting the right formula.